In this video, we're going to be learning about turning points. The maximum number of turning points is your degree minus 1. And for the first couple of problems here, I'm given the first part of a polynomial, and we're going to assume the polynomial is written in descending order. So for problem 1, the degree of my polynomial is 5. The maximum number of turning points is going to be 5 minus 1, which is 4. Problem number 2, my degree is 8. The maximum number of turning points is going to be 8 minus 1, which is 7. Now I want to point out that I don't know how many turning points there are, but I do know the maximum number that there can be. In this problem, we're asked which of the following cannot be the graph of an equation with degree 5 and why. And there's a couple of different things that I can look at to help me figure out this answer. But with this particular lesson, we're looking at turning points. And I know that if I have degree 5, the maximum number of turning points is going to be 5 minus 1, which is 4. Choice A has 4 turning points. Choice B has 2 turning points, so that could possibly be degree 5. And choice C has 1, 2, 3, 4, 5 turning points, so the answer here is C. Problem 4, determine the minimum degree of the polynomial function graph. One thing I want to point out about this graph is that there are no real zeros. So I really cannot look at the zeros of this graph to help me determine anything. So I need to be looking at turning points. There are 5 turning points, so I know the minimum degree is 6. Problem 5. Which of the following could be the equation of the graph shown? Now we've seen this exact problem before when we were talking about zeros and multiplicities, but I want to look at this equation in relation to turning points. I have 1, 2, 3 turning points, so the least degree is 4, so that only leaves me that last option as a possibility. Pause the video and see if you can do this problem on your own. Now we have 3 turning points, so I know the least degree is 4. For the next 2 problems, we are approximating the turning point located on the given interval and round to the nearest hundred. So for these problems, we are going to be using our graphing calculator. For problem 7, I've entered my equation into my calculator. I'm going to look at my graph and see if my window is set appropriately. I can see my turning point in this window, but I'm going to zoom in. That's just a personal preference of mine. You may not want to do that, but I'm going to change my window so I can see that a little bit better. When you look at your graph here, you need to identify whether you have a minimum value or a maximum value for your turning point. And in this case, it is a minimum value. So I'm going to hit second, trace, and I want that third option, minimum. I do want to point out that this minimum value is not necessarily a minimum value of the whole graph, but it's what's called a local minimum. Once option 3 is highlighted, I press enter. It will take me back to my graph, and notice my cursor needs to be moved. I want to move that to the left of the minimum value. Press enter. Then use my arrow key to go to the right of my minimum value. Press enter. Then press enter one more time, and I will have my minimum value at the bottom of my screen. This is the x coordinate, and this is the y coordinate. So there is your answer for problem 7. For problem 8, I've entered my equation into my calculator, and I've set my window to where that I can see my graph easily. And the turning point that's in between -1 and 0 is a maximum value. So second trace, that I'm going to select option 4. Be sure that's highlighted and then press enter. The calculator is asking me for the left bound, so I'm going to arrow over, press enter, then go to the right of my maximum value, press enter. It's asking me to guess, press enter one more time, and there's my turning point.